Hi everyone, today I will be showing you the Cary 5000 UV-Vis-NIR spectrophotometer. So this is a high precision instrument used to collect the spectra data from 175 nanometer to almost 3300 nanometers, near infrared region to the UV region. This is the instrument that we use, and we have a system that actually helps you to visualize the data. Here you can see there is a power on off button. So I have already turned it on because we should always turn it on at 20 minutes prior to our data collection. As you can see, I have already prepared two samples that I want to collect data. So I just marked it as C1 and C10, which is actually the compound's name. This is your sample holder of the instrument. You can keep a 1 centimeter into 1 centimeter cuvette, and you can go all the way down to 0.1 mm thin film slides, and you can see that there will be light coming from this lamp on this side, and there will be a sensor on this side that will actually collect the data. And here you can see that so here you can adjust all the changes in the light. Like if the lamp goes wrong, you can change the lamp by the new one by opening that portion of the device, and then you can get back to your experiments. So after turning on the power button, you have to go to the scan option in your system. So you can see the option over here, scan. Click on it and you can open it. After that, you have to check whether the device is offline or online. So it looks like it's offline. It was offline, now it's online, and you have to wait for some time because all the setup, the zero should be highlighted properly. Now it's highlighted, so you can click on setup and you can change your scale. So here when you go to setup, you can see the first option, Cary, and you can change the mode from nanometer to wave numbers or angstroms or angle. Right now I am taking nanometers, as this is the way I am working on. Then I have to do it from 3000 to 4000 nanometer, and then we have like the options over here. So you can, if you want to change so there are like two lamps in this device, and if you want to change the lamp from the shifting of the lamps from one nanometer to other, you can change that nanometer value, and also you can change the detector and the grating as well. So from here you can change it, but I'm just keeping it that itself. And also if you want a baseline correction, you can click on this one. So when you click on this one, the baseline option on this one will be open, otherwise it will be just turned off. So now the baseline is opened, and you can just place your sample, which is actually the baseline of yours. Sometimes it will be the cuvette alone or the cuvette with the solution. I am working on chloroform as the solvent, so my baseline is chloroform plus the cuvette. Since I have already done this baseline correction, I don't need to do it again. There is an option called zero where measuring the zero absorption level. I'm going to place my sample. One thing about the placing the sample is that there is the transparent region in the cuvette, and there is a translucent region in the cuvette. So you should be careful that the transparent region should be directly aligned with this source and the detector. So I'm just keeping it like that. Then you should be sure that this one is closed properly, otherwise there will be a lot of noise in your data. After placing the sample, we can press on start. Okay, so since I have already done the baseline correction, though I don't need to do that again, so I have to turn off the baseline setup. So go to the baseline, and I just turned off the correction, then okay. Now we can go for the start. You have to give a file name, this is the sample name, which is actually the data that is shown in the graph. In my case, it's a ratio of different chemicals, so I'm just doing 100:10:1, which is actually the ratio of the chemicals. So it will take some time to finish the spectra. Now we have finished our reading for the first sample, and we can take out the sample when there's this green light turned on. We have done with our data collection, and now we have to save it in a CSV file. These files are actually saved in DSW and BSW data, which is not compatible with most of our PCs and laptops. For data visualization, we have to change it to CSV file, so you can export the data to an Excel file or a Origin or Python or whatever. You have to go to File, press Save Data As, then go to, so you can type a name for the file. For me, I'm giving data as cyano, so that's my compound name. And so then here we have to change the files of type into CSV file, spreadsheet ASI CSV file. So this is very important, otherwise you won't be able to see the data in your system. So then go to the save, then you can see your data saved in a CSV file. So I can show you my CSV file. This is my CSV file, and you can see that I collected two data of two different samples, which I gave the heading as 100:10:1 and 100:10:10. The wavelengths are from 3000 to 400 all the way down, and this is the absorbance, and similarly for the second one as well. You can see it over here. These are the data that we that actually came with the measurements, which is the collection time, operator name, the software that we used, the instrument, everything. Now we need to transfer the data from the system to our pen drive. So thank you all for watching the video, and stay tuned for the next one.